African goshawk, the ultimate flying animal, with the sharpest eyes on Earth, can spot its prey and agilely maneuver in a dense forest. A perfect balance between the two tasks. How can we humans even compete? We were trained from the Stone Age to spy the prey from a safe location, approaching with projected weapons. Our logical understanding of the scene provides us the ability to semantically analyze our surroundings. However, our neural system has never developed to adapt to flying, not to say an agitated one. Human operations of flying machines have not been over a few generations. The skill set of drone racing pilots are built upon rehearsals. We're not born to fly in an unfamiliar environment. On the other hand, modern lightweight sensors can see in the scope of hundreds of meters, with an accuracy less than a centimeter. Coupled with contemporary planning algorithms, a robot can compute its passes faster and better than human beings. Making the best out of the two, scientists and engineers at Earth Autonomy and Carnegie Mellon University have developed a human-guided safety flight system. A pilot with a remote controller to communicate with the robot gives the high-level directions of where he or she wants the robot to go. The onboard safety navigation software computes the exact passes to fly based on the given directions. After 3 months of technical development, the team conducted the first flight test at a remote orchard, privately owned and far away from public traffic. April 11th, 2018. Partially cloudy. 12 degrees Celsius. Wind at 6 meters per second. Flight test was successful. Maximum speed reached 5 meters per second. At the same time, technical development in the office continued. Engineers examined the data collected in the field, refined the system on board the robot, and moved on with further implementations. May 7th, 2018. The second flight test was planned to fly through a tight opening. Clear with broken clouds, 26 degrees Celsius. Wind at 2 meters per second. Maximum flight speed at 10 meters per second. With 2 flight tests down, one is yet to accomplish. The team didn't slow down. For the last flight test, the robot would be operated in dense woods at top speed. For the single flight test, the team was given 2 months to prepare. 2 months would have been long, but was barely enough. At the end of the day, the flight test kept going in the engineers' minds. July 6, 2018. The team arrived at the test site at 9:30 in the morning. Partially cloudy, 25 degrees Celsius. Wind at 5 meters per second. Everything was set up and ready to go. Six months went by, and the team has accomplished well to celebrate. Year after year, scientists and engineers at Earth Autonomy and Carnegie Mellon University are carrying out the most advanced technologies the world has to present. The project has the potential to bring aerial autonomy to the industry, assisting pilots to keep the aircraft safe. When the next project starts, the technical development will resume, and the flight test will take place. The process will go on and on.